Algebra 1, Lesson 65. Today we're going to talk about writing equations of parallel and perpendicular lines. Let's talk for a second about parallel lines. Where do you see parallel lines? Things that are parallel to each other. Where do you see those at? Do we need to... Okay, lines on the road. And that could be the white lines on either side of the road. That could be the two yellow lines in the middle. You see those two lines in the middle. What does that mean? Right, no passing. Right, you're in a no passing zone. You get those double or those parallel lines. Do parallel lines ever touch? No, they'll never touch. All right, and the reason that they'll never touch is because they have the same slope. Okay. And more specifically, on a coordinate plane, they have the same slope, but a different y-intercept. If they had the same y-intercept, they would be the same line. Okay? Let's see. Let's try to look around the room here for a second and see if we can spot some parallel lines, whether in the room or maybe directly outside the room. Do we see anything? Lines are, yeah, blatant. Lines on the American flag. Okay, the red stripes on the American flag. Okay, anywhere else? Yeah, Anthony? The lines on the trophy. Okay, got those little black bars that run parallel to each other. If we look outside the window over here, notice, I don't even know what you call that, the ridges on the roof, right? Notice how those all run parallel to each other. Okay, we can look around the room and we can see the little border lines of all this little stuff here, and none of that stuff intersects. Right? You can find all kinds of places. In fact, just about everybody here is sitting here with a notebook sheet of paper, right? Look at those blue lines that are on there. Right? You got blue lines on your notebook paper that never cross. Now, what about perpendicular lines? What do we know about perpendicular lines? They intersect, but they intersect very specifically. They intersect how? Bless you, by the way. What's that? At 90, I heard 90, and I heard 90. Well, I don't think you said 90. What did you say? Right angles. Okay? Right and 90 are the same thing, correct? Can we see any perpendicular lines around the room? Either whether directly in the room or directly outside of the room. The trim where it meets, so like maybe looking up here where this trim piece around the whiteboard meets this trim piece here, right? Comes together at a right angle, sure. Keyboard has lots of right angles on it, okay? Let's go back to your notebook sheet of paper, right? Are there any right angles there? The red line on that left-hand side is perpendicular to all of those blue lines, correct? All right. Now, what do we know that parallel lines have the same slope. What is the relationship of perpendicular lines with their slopes? They are different, okay? And if you don't know this yet, we're going to find it out today. We're going to find out exactly what that relationship is. So let's kind of go back to parallel lines. Parallel lines are lines that are in the same plane but do not intersect. Two non-vertical lines are parallel if they have the same slope but are not the same line, meaning they don't have the same y-intercept. Okay? Any two vertical lines are parallel. Okay? So if those two lines go straight up and down, and they have no run, right? They have rise and fall, but no run. Two vertical lines are always going to be parallel. The same way with horizontal lines. All horizontal lines on a coordinate plane are going to be parallel. Does that make sense? I mean, you see that on your notebook paper. Okay? Here we have an example. This is, now granted, you can find this example in your book where it actually has all the numbers and everything on it. I just kind of free drew it with some lines. And you have an example here of two equations. One is y equals 2x plus 7. The other is y equals 2x minus 1. What is their slope? What do they both have in common? A slope of 2. All right? Now, x isn't the slope, but the number that becomes before the x is the slope, right? So if you get a question on your test where it says, okay, here's y equals 2x plus 7. What is the slope? Are we going to say 2 or 2x? 2. Okay, just 2. All right, so they both have a slope of 2. Do they have the same y-intercept? No, so they are different lines. Okay, they have to be different lines. Okay, so those are the graphs of 2 parallel lines. And they will go on in each direction forever and never touch each other. Okay, perpendicular lines are 2 lines that do intersect, but they intersect very specifically at right angles. We can make all kinds of intersecting lines. Not all lines intersect at right angles. Any 2, and I've misspelled lines there, I apologize, are perpendicular if their slopes are negative reciprocals of each other. So it says negative reciprocals. What we have a tendency to say, and how I prefer to say, is opposite reciprocals. Okay? So if I have a slope of 1/2, then the opposite of that is going to be negative, right? The reciprocal of 1/2 is going to be 2/1. Does that make sense? So the equation 1/2, or a slope of 1/2, is going to meet at a right angle when I have an equation with a slope of -2. You follow me so far? Okay, so they are opposite reciprocals in terms of their slope. A vertical and a horizontal line are also perpendicular. So if I see an equation where it says x equals, say, 4 and y equals 6, right? Those are examples of equations of horizontal and vertical lines. All horizontal and vertical lines are perpendicular. Okay? Any vertical line is going to be perpendicular to any horizontal line. Here we have a quick example. We have a slope where it's y equals 3x minus 7. That slope is 3. We have an equation with the slope of y equals -1/3 x plus 3. It has a slope of -1/3. Since those slopes are negative or opposite reciprocals, the lines are perpendicular. Questions so far? We get it? Okay. Remember being in elementary schools, is there stuff from elementary school like the teacher said a lot that you still remember as like little catchy little phrases? I always remember as a kid, I had teachers that would say, "Get it, got it, good." And I just heard that all the time. So it still kind of runs through my head today. So do we get it? We'd say that we got it? Good. Okay. Let's see. Hopefully here. All right, so we got an equation. It goes through coordinate -1, 1, and is parallel to y equals -2x plus 1. We want to know which equation it is. So what we're going to do is we're going to go back to an equation that we've already used. All right, are we familiar with y minus y1 equals m times x minus x1? Yeah, we remember that. Okay? Now, if I want an equation that's going to be parallel to y equals 2x plus -2x plus 1, what do I want to use for my m in the equation I'm going to write? I want the slope from the equation that I'm comparing it to down here. What is the slope in that equation? -2. So where am I going to plug that in into my point slope formula up here? Into the m. So, okay, so I know that that's -2. Okay? Now, the other piece of information, and that's all the information I need from that equation, right? The other piece of information I need to use is right here, okay? Where am I going to put that -1 and that 1 at? Okay, so I'm going to plug in this 1 for x1. So we're going to go -1. Okay? And what about this -1? I'm going to plug that in for what? y1. So, now granted, here, let me kind of clear that up, that we're just using 1 there, and here we're using -1. And now I need to finish it, right? So I'm going to do y minus -1 equals -2 times x minus 1. And we're going to solve from there, right? Okay, what's the first thing you do, Jeremy? Distribute the what? Okay. So tell me what that distribution looks like.
Negative 2x times, or not times, negative 2x.
So you got negative 2 times x, good. And now negative 2 times, okay, what's negative 2 times negative 1? Positive 2. Okay, let's come over here. Let's see. Anthony, I got y minus negative 1. Can I rewrite that at all? One minus negative 1? I can't rewrite it. There is something I can change, though, right? Notice how it says y minus negative 1. Can I simplify that at all? What happens whenever I have double negatives? It becomes positive. So can I rewrite that as y plus 1? Okay. Now, I still have something left to do, right, Jordan? What do I need to do? Okay. We're hoping to get an equation that's going to look like y equals mx plus b, except with numbers for m and b. But right now it doesn't look like that, does it? Right? I got this y plus 1 equals. So I just want it to be y equals. So what needs to move to the other side? The 1. How do I move it over there? Subtract 1. Okay? What do I want to subtract 1 from on the other side, though? Okay, so I'm going to subtract it from there. I'm going to get an equation of y equals negative 2x. What's 2? Positive 2 minus 1. What is it? Plus 1. Okay, y equals negative 2x plus 1. All right, do we see that answer up here anywhere? Which is incorrect, right? Did I mess up somewhere? We got our 1's in the wrong places, didn't we? All right. And that's a really easy mistake to make, right? That this x, because they got to switch sides, right? So this should go here and this should go here. Listen, you see me make a really obvious mistake, stop me and say, hey, I think we got some of these things in the wrong places. All right, yeah, this should have been here, and this should have been just like that, right? Okay? Which, let's see, we're going to get y minus 1. Okay, and we're going to get over here. Let's fix some of this up here. We're getting negative 2. That's positive, so this would be, what, negative 2? Right? We're still, at this point, we're going to, let's see. We got y minus 1 here. We need to add 1 to both sides. What's negative 2 plus 1? Negative 1. So our answer is here. Good catch. And this is why we watch the whole video, because Mr. Wilcox does make mistakes that sometimes don't get fixed till the end. Okay. And so you got a lot of questions in here about identifying lines that are parallel. We can tell right off the bat that lines 1 and lines 3 are not parallel, right? How can we tell that lines 1 and 3 are not parallel? Because they don't have the same slope, right? But what do I need to do with lines 2 and lines 4? Simplify them. I need to put them into y-intercept form, correct? Yes? All right, so looking at this, I want to solve for y. What do I need to do? Move the x to the other side. How am I going to do that, Blayton? Okay, so I got 1/5 y equals negative x minus 6. What do I want to do now? What needs to move to the other side? The 1/5. How do I move 1/5 to the other side? Can I divide by a fraction now? No, but I can multiply by the reciprocal. Okay, so I'm going to multiply this side by 5 over 1. I'm going to multiply this side by 5. So now we're going to distribute, right? What's 5 times negative x? Negative 5x. I get negative 5x minus 30. All right, is negative 5x minus 30, is that parallel to anything? Is there anything else up there that it would be parallel to? What line would that be parallel to? Line 3, because it has a slope of negative 5, right? So lines 2 and lines 3 are parallel. Does that make sense? Now, I can tell right off the bat here that I'm going to take negative 1/7 and multiply that by x, and that's going to give me my slope, right? Okay, so that's got a slope of negative 1/7. Does anything else have a slope of negative 1/7? Does line 1 have a slope of negative 1/7? No. Okay, I think we're making this harder, or we're trying to make it harder than it really is. If they're not the same slope, then they're not parallel, right? So lines 2 and lines 3 are the only ones there that are parallel. Now, I do have to check everything because I can get a test question where it's lines 1 and lines 4 are parallel and line 2 and line 3 are parallel. Okay, we got not a lot of time left here. Is there anything from your homework that you want to look at quickly? All right, so you want to remember your equations. You want to look at your example questions, okay? We'll grade this assignment tomorrow. I think it's only something like 13 questions. So you guys should be in good hands.